Hi, we are from Group 35 for KNP 3053 Manufacturing System Assignment. We are going to present our product that can be found on the back of a commercial airplane, which is the empennage. Our group members consist of myself, Andre Nicholson anak Felix Ospi, Asfar Haziq bin Abdul Jalil, Delfron anak Donald, and Ian Wagner Ruhin anak Frederick. For the introduction, the purpose of this project is to conduct a feasibility study of designing the plant layout and process in the production of an airplane empennage. The main components that are involved in the manufacturing process are the plant layout, types of operation involved, selection of material transport, machines used, and the storage system. The goal of this project is to devise a proper plant design to improve the production capacity and production rate to prepare the product to be marketed in 2024. But to maximize the manufacturing rate of airplane empennage, our company has made the decision to come up with an alternative plant layout design.
Hello everyone, my name is Asfar Haziq bin Abdul Jalil. My metric number is 73372. For my part, I will present about background. Our team have choose commercial airplane as product type for this assignment. First of all, let me tell you short history of the first airplane. The first airplane has been invented by Wilbur Wright and Orville Wright. In 70 December 1903, the Wright brothers tested 3 flights. The first flight lasted for 12 seconds and covered 36 meters, while the longest one is covering 255 meters in 59 seconds. Next, we know that there are many components in the aircraft, but the main component is fuselage, wings, empennage, and landing gear. Our team have decided to make a plan to improve the production of empennage, which also known as tail section. It is consist of vertical stabilizer, horizontal stabilizer, rudder, and elevators.
Good day everyone, my name is Delfron Anak Donald with metrics number 73416, and as for my part, I'll be explaining on the manufacturing system of our product. So manufacturing system in general is described as a system that is associated with humans, tools, machines, and processes for the productions of goods and services. It normally involves the methods of raw materials acquisition, manufacturing, processing, and assembly, and also distribution. So manufacturing system transforms raw materials into products of higher value via manufacturing process and assembly, which also adds value to the material by altering its shape or properties or mixing it with other materials that have been similarly changed. When building a model of any kind, it is important to make sure that all of the various pieces of the model are aligned and securely attached to one another. This is important not only for aesthetic reasons but also to allow an operating model to function properly. One of the most important sections to assemble with respect to a model airplane is the empennage section. So this section, which is also known as the tail assembly, includes flight control surfaces known as the vertical and horizontal stabilizers. So in order for an aircraft to properly fly, the empennage must be precisely aligned and attached to the fuselage. The need for this alignment is highly crucial as the empennage and its component parts, the vertical and horizontal stabilizers, are critical to the control and stability of the aircraft. So the vertical stabilizer, which is also called the tail fin, includes the control surface known as the rudder. The rudder is used to control the aircraft's motion along the yaw axis and thus allow the nose of the aircraft to move in the direction of left to or right. So this rudder is also important in aiding the pilot with maintaining what is known as balanced flight during a turn. This is because correct positioning of the rudder results in the tail of the aircraft directly following the line of flight of the nose of the aircraft through a turn, thereby eliminating a skidding or slipping of the aircraft. So the horizontal stabilizer controls the aircraft's motion along the pitch axis, which controls the movement of the plane flying upwards or downwards, which allows the nose of the aircraft to pitch up or down so as to allow the airplane to climb or descend. Both the horizontal and vertical stabilizers work in conjunction with the ailerons on the wings to allow the airplane to move in all three axes, which are the yaw axis, pitch axis, and roll axis. So needless to say, if either the vertical or the horizontal stabilizer should separate from the aircraft, therefore catastrophic results could occur. So for this reason, it is highly important that a model aircraft have an empennage assembly that can be easily and securely fastened to the fuselage. So this invention also relates to a method for attaching an empennage assembly to a model aircraft. In an embodiment, this method includes the steps of the first one, which is placing a horizontal stabilizer on a top portion of an aircraft fuselage so as to align a hole in the horizontal stabilizer with an opening in the bottom portion of the fuselage. The second one is to insert a housing in the opening in the bottom portion of the fuselage and the hole in the horizontal stabilizer. The third one is to align a vertical stabilizer having a rod existing from an underside thereof with a hole in the horizontal stabilizer. The fourth one is to position the rod in the housing, and finally is to secure the housing to the rod. So the manufacturing process of an empennage begins with the building and planning of the design using computer software and drawings that involve mathematical calculations. Airplanes having two or more components need to be welded together, where this process is compulsory to meet the strictest and specific safety regulations and standards. The rib is constructed of aircraft-grade aluminum, which is corrosion resistant and has a high tensile strength. A computer-guided stamping machine punches holes for rivets and control wires to create empennages structure, which also help to lighten the weight of the aluminum alloy. Next, the worker will break the micro-joint attachments and retrieve the ribs. The rib is then placed in a forming die, which is then stamped into the die form by using a high-pressure hydraulic press. A grinding machine is then used to smooth down the rough edges. The plastic coating that shields the ribs from scratches is carefully peeled off in a manual method. Spars go through the same procedures as ribs. Drilling is carried out for rivets used in the installation of rear spars and ribs to main spars. An overhead crane raises and transports the heavy aluminum across the facility for the empennage fin. When it arrives at its destination, a milling machine cuts or shaves the aluminum surface in order to reduce the weight while preserving its strength. Finally, it is baked, and the heat must be kept consistent over the entire panel. The panel assembly line, known as PAL, which is a robotic drilling update, will drill the panel and leaves the employees to add the rivets. As for the assembly of the plane empennage, the assembly line is built around a flexible, modular monorail system that runs from the product design through manufacturing planning. This method allows for the assembly of both stabilizers at specified rates, and due to its flexibility, may absorb rate variations and be changed for new products. Panel drilling and fastening are then handled by robots. Handling systems help employees move large and heavy items to and from the assembly line. The assembly of the empennage onto the fuselage is done by aligning them with laser guidance for accurate and precise assembly. All of these applications result in high quality goods and highly efficient manufacturing procedures, resulting in a more sustainable means of producing aeroplane components. Next, the completed and inspected parts of the airplane empennage are sent to the main factory of an airplane company that has a production line. There may be a dedicated production line for the tail wing and fuselage assembly on certain parts of the plane, especially for exceeding large planes. Finally, after the assembly, the entire plane is thoroughly inspected for any possible defects. Following the approval by the inspector, the plane will then undergo a series of flight tests to ensure that all systems are functioning properly and that the plane is functioning smoothly without any problems. After passing all the tests, the plane is ready to undergo a final fix, including internal compositioning, painting, or cosmetic work. Succeeding this stage, the plane is finally ready for delivery to the customer. The fixed position layout is implied by this product. As seen in the figure, the main frame of the empennage remains in place as the employees and equipment move to the production area. Such layout is chosen because large projects are too big to move. Hence, the equipment and parts move in and out of work areas. Therefore, highly skilled workers play a huge role in this process in order for the production line to run smoothly and efficiently. So the production machines involved in the manufacturing of an airplane empennage includes an industrial oven, which is the baking machine that is a heat chamber that was pressurized and cooked the airplane fins. Next is the grinder machine that smooths away any rough edges and the stamping area. Next is the hydraulic press machine that presses the forming die so that the aluminum conforms to the shape of the die. Other production machines involved include the overhead cranes that is used to raise and transport the heavy aluminum throughout the factory. Next is the panel assembly line, or known as PAL, that drills the panel in preparation for riveting. And finally is the stamping machine that punches, rivet, and control cable holes where larger holes are punched to save weight. Moving on, computer control system is a high reliability computer, different control modules with dependable properties, a motor drive unit and numerous sensors provided with a software control system. Overhead cranes are utilized to raise and transport the material, where the workers will be responsible to operate and regulate the movement of the overhead cranes in the plant with the use of controllers. In order for the operation of stamping process to continue, the orientation or space for punching is pre-programmed within the computer system. When punching the holes, the stamping machine then follows the specified features that were pre-programmed in the computer. A 3D contour map is kept in the computer of the automated milling machine, which therefore allows for a precision cutting edge of the milling machine to cut across the surface of the aluminum alloy metal sheet in a back and forth motion until the 3D contour map is matched. In the process of baking, the temperature of the oven is to be distributed evenly and remained constant throughout the whole process, which is set by the worker in charge that allows the oven to run the process, tendering the input. With the advancement of computer control system, the enhanced robotic technology, the panel assembly line, or known as PAL, will replace the usual hand drilling of the panel. The empennage is assembled onto the fuselage by aligning them using laser guidance for accurate and precise upon the assembly of the components of empennage, which include the stabilizer, elevator, rudder, and fin with the use of fasteners. Next is the remote monitoring and control system, which are also utilized in this manufacturing line in order to optimize the production processes that are too complicated or intricate for human employees to perform successfully. For worker safety, the system can monitor the status of each equipment. As a result, if any machines fail in the production, the sensor may identify and report the malfunctioning machines to the management. Hence, there is no need for human to check the machine's status, therefore reducing the amount of labor necessary for routine maintenance. Therefore, the device is thus capable of monitoring the workers' productivity. That is all for my part, and I'd like to pass it on to my fellow group member, Ian Wagner, to further explain on the human resource section. Thank you.
Hi, my name is Ian Wagner Ruhin, metric number 73493. And for my part, I will be discussing on human resource, material transport system, and storage and identification system. First of all, what is human resource? Human resource management in aviation is in charge of planning, implementing, and evaluating the workers working in the aviation industries and its function in the industries in concern with payroll, administrative tasks, and direct labor. However, uh, in a manufacturing industry, it focuses more on the direct labor. Here, there exist two types of system, which are manual and fully automated system. Manual system refers to direct labor. It refers to human being, and they perform some part or all the manual work to produce parts or product for the airplane. And in a completely automated system, it is fully operated by pre-programmed system. However, even though it is fully automatic, direct laborers are still needed to perform tasks like loading and unloading, and parts positioning and tool maintenance. They are also in charge as the operator of the system, such as programmers for the CNC machine tools and computer operators. In our case, fully automated system is more favorable since it has a precise cutting measurement, um, and it is cost and time saving since uh, from the beginning of the day until the end of the day, the machine will work non-stop to produce parts and compartments. Next is a material transport system. It is used to move materials from workstation to workstation, facilities, or inside warehouse. A few types of transport system, including AGV, trucks, conveyors, hoists, and cranes. In our case, we have two that is the most important. First of all, is hoists and cranes, where it is used to carry and transport massive loads and large size compartment of the airplane. And next is the AGV, or known as automated guided vehicles, which is used to transport smaller size of the empennage or the parts during production phase. It is a self-guided transport, and it is crucial to move small but dense payloads from one location to another. Next is the storage and identification system. Storage has many factors that we need to determine, such as the shape of the product, condition, size of the image, and the size. Whereas for the identification system, it is a technology which have a unique symbol, number, and code for each product that is stored. In an aeroplane hangar, it is preferable to use open racks as we want free flow of air in the factory. And next, small parts and assemble materials such as screw and bolts are stored in containers. Next, the technology used in identification system is automatic identification and data capture, or known as AIDC. It is a technology that accurately captures and identifies data, collect and creates a barcode. The most common type of automatic identification system is barcoding. I think that is all from me. Thank you.
In conclusion, our team was successful in creating a suitable and workable business concept that may benefit the industrial sector. Our proposed manufacturing system will increase empennage production for aircraft. Lastly, we'll also cut the production cost by applying this automated process that help to cut down human labor, as mostly of the job and process are done by machine. So we think that we have achieved sustainable development goal, which is SDG 8, decent work and economic growth. I think that's all from our group, which is group 35. Thank you.